friends, hope you all are doing fine. In my previous video, I discussed what is resistance, its symbol, unit, and cause of resistance. In this video, I'll be discussing factors on which resistance depends, specific resistance, fixed and variable resistance. Resistance of the conductor depends on these factors: length of the conductor, cross-sectional area of the conductor, nature of the material of the conductor, and the temperature of the conductor. Let's discuss each point in detail. Length of the conductor. Suppose you have a big and a small wire. Now in big wire, as length is more, so electrons have to travel longer distance. So they suffer more opposition on the way. That is more hindrance and stoppage on the way, so more resistance. While in short wire, electrons have to travel less distance, which means less opposition, hindrance or stoppage, so less resistance. It's exactly like when you have to cover longer distance. Suppose you are going from Delhi to Chandigarh, so it's very obvious that you get more traffic and red lights on the way, which will reduce your speed and hence take more time. Whereas, if you go nearby in your area, you will get less traffic and red lights on the way. And this will increase your speed and you will reach faster. So, remember, resistance is directly proportional to length. More the length, more is the resistance. Second factor is cross-sectional area of the conductor. Suppose you have a thick and a thin wire. Now in thick wire, electrons or current will be able to travel freely as there is more space. So less stoppage or hindrance, and this will increase the speed of electrons or current. Hence, less resistance. As we all know, if current is able to move freely in a wire, that means it has less resistance. Whereas, in thin wire, electrons will not be able to travel easily as space is less, so they will bump into each other, and this will reduce the speed of electrons or current and hence more resistance. Let me give you an example. Imagine that you are going on a huge highway, so you will get less traffic and this will increase your speed. So that means less stoppage or less resistance. Whereas, imagine that you are in a congested old Delhi market where you get more people, more traffic, more stoppage, and this will make your speed very slow. So more stoppage, more resistance. So remember, area is inversely proportional to resistance. More area, less resistance, and less area, more resistance. Third factor is material of the conductor. If we take two wires of same length and thickness but of different material, that is, one of copper and other of nichrome, you will notice that nichrome wire has 60 times more resistance than copper wire. That's why nichrome is used in heaters to give heating effect. So more resistance means more heating effect. Fourth factor is temperature of the conductor. In metal and alloys, resistance increases with increase in temperature. When temperature increases, the collision of electrons within the wire also increases, and this reduces the flow of current, which increases the resistance. After studying the factors on which resistance depends, we come to conclusion that resistance is directly proportional to length and inversely proportional to area. Now combining these two and removing proportionality sign, we add a constant here called rho. This constant is called resistivity or specific resistance. Formula for resistivity is rho is equal to Ra upon L. Its SI unit is ohm meter. Resistivity does not depend on length or area of the conductor, but it depends on temperature of the conductor. Last we come to types of resistance. Under this we have fixed resistance called resistors as shown in the picture, which I have already covered in my previous video. Their value does not change. Next we have variable resistance, also called rheostat. Their resistance can be changed by changing length and area. That's all for this video. Thanks for watching.